All right, so discrete functions, lesson 3, and it says we've done a lot of modeling, okay, this year. Meaning you're taking some application type of problem and doing something with it. It's not just that exercise for your brain, okay? The modeling is the real life application reasoning kind of questions. So it says, each time we use the function to describe the relationship between two quantities, the input, typically x, was either continuous or discrete. Okay, so we got two words there, but we've talked about continuous and discrete functions before. So it says continuous variable function takes on all real number values, everything. And then a discrete variable function takes on isolated or unconnected values between its extremes, meaning between its endpoints. I think when we talked about these, there was a question that talked about carnations and roses. And we had to graph it, and we said, why is the graph a bunch of dots without stuff connected? And we said, you can't have part of a flower. Okay? I think that was the question. Okay? So it says, in this lesson, we will concentrate on discrete functions. A lot of times they're items, they're things. Okay? Because most of the graphing that we've done has been continuous. It says, Miranda has a lemonade stand where she is selling cups of lemonade for 50 cents per cup. Okay? Cups of lemonade, things. It says, fill out the table below for the amount of money M that Miranda makes as a function of the number of cups that she sells. So if she sells 0 cups, she has $0. If she sells 1 cup, she's got 50 cents, $1, $1.50, $2, right? Is she ever going to make $1.75? No, because what are they? They're charging how much per cup? 50 cents. We're not talking about if somebody gives her a tip or if somebody shortchanges her. We're talking about straight up 50 cents a cup. Explain why this is an example of a discrete function. Okay? So this function, the inputs, okay? The inputs are only going to be integers. Okay? Even if she sold partial cups, say half a cup, okay, she didn't fill it all the way up, there still would be amounts that she wouldn't sell. So we still got, okay, the inputs, which are the cups, it says integers, but I would venture to say they are what type of integers? What type of integers? Positive. We sell negative cups? No. Okay. Create an equation that finds the money made M as a function of the number of cups C. You've got to use those two variables. So what's my equation? M equals what? 0.5 what? No, what did we say? C, yeah. 0.5 C. Graph the function on the grid below. So now think about this. This is a discrete function. So if we sold 0 cups, we made 0 money. If we sold 1 cup, we have 50 cents. But if we sold 2 cups, we're going to have $1. It's just kind of easier not to graph the 50 cents, the in-betweens. So 4 cups, we've got $2. You can see, okay, the slope occurring. We're not going to connect them, because if we connect them, that indicates that, oh, maybe she's got $2.13 or $5.75. That's not happening. So it says, how many cups of lemonade would Miranda need to sell in order to make $30? How many? 60 cups. Okay. So if I want $30, okay, I know that C is going to have to be 60 cups. Explain why Miranda cannot make exactly $28.75. Okay, we said they're 50 cents a cup. She's never saying, oh, I'll give you a deal if I only give you half a cup of lemonade. Okay. So she can only make amounts in 50 cent increments. Okay. The cups are integers. The inputs are integers. All right, go ahead. So discrete functions are characterized by domains or inputs that realistically contain only certain types of numbers, and typically they are whole numbers. Okay, somebody mentioned whole numbers, they're positive integers. So in each of the following cases, two variables are related by a function. In each situation, tell me, continuous or discrete? Explain your thinking. So I'm going to pause it. Okay. All right. Phenomena that are discrete, okay, often have ramification when it comes to realistic solutions. Okay, realistic solutions to modeling problems. Consider this example, okay, about texting plans. Okay, Malik is trying to compare texting plans for two cell phone companies. His options are, so we got option A and option B. We've got a monthly charge and a text cost, no monthly charge, and a text cost. Write equations that give the total monthly cost C. Make sure you use those variables based on the number of texts made N for both options. So talk to me. Who's got A? Use those variables. Option A. What do you think, Simon?
So it's going to be like 1250 M?
No? For option
No,
A.
plus 1250
Give me the equation. M.
C equals X to N plus 12.
Okay. B. And okay. Why will Malik not be able to find the number of texts where the two plans charge an equal monthly amount? So let's set them equal to each other. Okay, set the two plans equal to each other. So plan A equals plan B. Go ahead and solve that equation for N and then answer the question. Liam, what'd you get for N? Okay, when you solve that, you get that. Okay, and so that's the number of texts. Okay. Why will Malik not be able to find the number of texts for two plans equal a monthly amount? Okay, so context of the problem. Right. Okay, texts are or inputs have to be integers. Okay. Inputs, okay, which are text, are integers, whole numbers specifically, okay, here. So it says even though the solution B is not viable, okay, it's not good, okay, it still might be helpful in thinking about two cell phone plans. What information does it provide? So if we think about, if we were to graph these two, okay, we're going to get two lines. And those two lines are going to cross at 416.6. So what would this tell us? Okay, this isn't helpful, okay, to tell us when they're equal, but what could it tell us?
Like what you how when the option B would be more expensive than option A.
Yes. Okay, it's going to help us compare up to, okay, say 417 texts, or from 0 to 416 texts, okay, which plan is going to be cheaper? And then at 417 and beyond text, which plan would be cheaper, okay? So option B is less expensive from 0 to 416 texts. Once we get beyond that, then it would be option A, would be least expensive. Okay? Okay? Good?